In the next part of the chapter, we're going to be studying matrices. Matrices are a way that we can organize a lot of different information into one mathematical thing. So here we can see a matrix, and our matrix is made, in this case, our matrix is made up of 6 elements, A, B, C, D, E, and F. And then also, what is important to know is that these are called your rows. We have 2 rows here. And it is also made up of 3 columns. So the rows and the columns are important because that is also how we name the size of a matrix. So these are our rows, and these are our columns. Whenever we are saying the size of a matrix, it's always going to be the number of rows by the number of columns. So in this case, it is 2 by 3 matrix. The size of the matrix is very important because when we talk about different mathematical operations, whether adding, subtracting, or multiplying, it's all going to be based on the size of the matrix. We can't just add or subtract any matrix with any other size matrix. Same thing with multiplication. The size of it does matter, whether what the rows are and what the columns are. So remember, always rows first, columns second. And as we build, once we go over the basic mathematical operations, then we'll look at some multiplying, and then ultimately we'll look at how we can solve a system of equations using matrices. To add or subtract matrices, they must be the same size. So in other words, if we have a 2 by 3 matrix, we can add it with another 2 by 3 matrix. But let's say I have a 2 by 3 matrix and a 2 by 2 matrix, then I cannot add or subtract them with each other. To add or subtract our matrices, all we want to do are add or subtract the corresponding elements. So corresponding, I mean, if we look at example A, we have matrix A plus matrix B. We could first see that these are the same size, 2 by 2 and 2 by 2. So when I talk about corresponding elements, I can see that 16 is row 1, column 1, and negative 4 is row 1, column 1. So I would add those together. Then I have row 1, column 2 is 2, and I will add that with row 1, column 2. Those correspond together. Then I have row 2, column 1, and row 2, column 1. Those correspond. And lastly, we have row 2, column 2, and row 2, column 2. Those correspond as well. So now let's go ahead and add these together. Okay, so 16 plus negative 4 will give us 12. 2 plus negative 1 is 1. Negative 9 plus negative 3 is negative 12. And 8 plus negative 7 is 1. And notice, guys, that our answer is going to be the same size. So a 2 by 2 matrix plus another 2 by 2 matrix will give us an answer that is also 2 by 2. Let's take a look at example B. We have matrix B minus matrix C. So first thing that we want to do is we want to see the size of these matrices. This is a 2 by 2 matrix, and this is a 2 by 1 matrix. So because we're trying to subtract a 2 by 2 matrix and a 2 by 1 matrix, this is not going to be possible because they are not the same size. So the reason it's not possible is because if we're looking at corresponding elements, there's no corresponding elements for these two here. Okay? We only have 2 rows and 1 column in matrix C. So we would just say that this is not possible due to matrix size. Looking at example C, we can see that we're doing matrix B minus matrix A. So again, first thing we're going to do is we're going to take note of what the size of these matrices are. So we have a 2 by 2 matrix and a 2 by 2 matrix. So since we are subtracting, they have to be the same size, which they are. So I know that I am able to subtract these matrices. With subtraction, we're just going to subtract the corresponding elements, which you can either do like the -4 minus 6, and of course we would get -20. Or sometimes what I like to do is I like to use the subtraction rule of adding the opposite. So I'll change that to the adding sign and then change these to the opposite. So 16 became negative, 2 became negative, -9 became positive, 8 becomes negative. And now it's just an addition problem. So sometimes that's easier to think of. It's really up to you how you want to do that. So we can see we'll have -20, row 1, column 1. 6 will go in row 2, column 1. -1 plus -2 is -3. -7 plus -8 is -15. So here's our answer. And again, we can see that it is another 2 by 2 matrix. We're going to skip example B for right now. We'll go back to that in a moment. And I want to take a look at what scalar multiplication is. Now, we can multiply matrices. However, that's not what scalar multiplication is. Scalar multiplication is almost like, think of it as distributing a single number to every element in the matrix. So when we're multiplying by a scalar, we distribute it to all its elements, meaning multiply. So if I'm going to do 5 times this matrix, I'm going to multiply it to every single matrix. Size of the matrix is not changing, so I'm still going to have a 2 by 3 matrix, and I'll have -60, 40, 30, -80, 20, and 95. So now taking a look at example D, we have 2a minus 3b. So we're going to use our order of operations, and we will multiply by the 2 and the 3 first before we do the subtraction. So because scalar multiplication does not change the size of a matrix, our answer is still going to be a 2 by 2 matrix. It's always good to know what the size of your answer matrix is going to be before you start a problem, especially when we get into multiplying. So first we're going to distribute out the 2. I'll have 32, 4, -18, and 16. And now I'm distributing out a -3. So again, sometimes people get a little confused with that minus sign, so if you want to add the opposite, and now I'm distributing out a -3 to everything, but it will be adding now. Okay, so I have 12, 3, 9, and 21. So now I can go ahead and add these two matrices together, and I'll have 44, 7, -9, and 37. And that is my answer of what 2 times the matrix A minus 3 times the matrix B is. The last thing we want to do is we want to look at a few properties of matrices when it comes to addition. So the first property that we want to look at is the commutative property of addition. And when we talk about the commutative property with multiplication, you think of it as order doesn't matter. So same thing with the commutative property of addition for matrices. The order does not matter. So if I am going to add two matrices together, A plus B, it's the same thing as if I had done B plus A. A and B are both matrices of the same size. That's important to note because otherwise we wouldn't be able to add them. Okay, our associative property of addition, again, similar to what we've done with associative in the past. Let's say I have A plus B and I do that addition first, and then I add C, matrix C to that result. That's going to be the same thing as if I added B and C matrices together first and then added A. So with addition, that will not matter. Now guys, notice I'm saying addition. These do not work always with subtraction. So just make note of that. And then our last property that we're going to look at is left and right scalar distribution property. So we have lowercase k is our scalar, which means it's a constant, it's a number, not a variable. And we are going to distribute that to matrix A plus matrix B. Then I can distribute it like this. The scalar times matrix A plus that scalar times matrix B. Okay? And so left or right scalar distribution, if I put the scalar on the right-hand side, it's not going to change anything. I'm still going to have k times A plus k, which is the scalar times matrix B. Okay, that is our first lesson with matrices. It's very basic with just the operations of adding and subtracting and scalar multiplication. So for homework, you have page 175 to 176, number 14, 17 through 20 all, and 24 through 27 all. So if you have any questions as you're doing this homework, feel free to message me on Remind or email me. And of course, I'll take any questions in the beginning of class the next time we see each other.